welcome again for this metallurgy subject and the second chapter which we have started as our academical part, that is mechanical testing of metals. Inside this non-destructive testing part now we have started. During last lecture we have seen the eddy current testing methodology, principle of working, advantages, limitations, applications, and now we are starting with radiography test. Myself, Dr. E.G. Kulkarni from SKNC College of Engineering. So as already discussed, these particular non-destructive testing methodologies are very important and useful because this does not cause any kind of damages. These are used for examination purpose, inspection purpose, as well as evaluation purpose. For all kind of this type of processes, these testings are used. Then during testing process, this does not permanently alter the specimen properties, and there is no any kind of economic loss. So that's why useful in case of various types of applications like transportation, pressure vessels, building structures, piping, hoisting equipments, etc. So eddy current method, magnetic particle method, dye penetrant method, radiographic, ultrasonic and visual testing methods are some important type of non-destructive testing methodologies, and today we are going to start with the radiography test. So that radiography test, inside which two kind of sources, that is either X-ray or gamma ray, that is used. So radiographic testing is type of non-destructive testing method in which either X-rays or gamma rays are used to examine the internal structure of manufacturing components, identifying the flaws or defects. For example, here you can see here that radiation source is given. So that radiation source will have either X-rays or gamma rays, and this particular rays will be passed through this specimen. So here the specimen is shown, inside which certain small flaw which is shown here, and due to the passage of the X-rays or gamma rays through this specimen surface, then it will through radiation sensing film. So there is one film you can observe here, this film is shown, and this particular film, so this is the radiation sensitive film, and from which it is possible to detect the position of the flaws, the size of the flaw, etc. And this is the developed film. Okay, so whatever the film is shown here, it is the developed film, and through this radiative sensitive film we can observe the position of the flaws, and a developed film will give the permanent type of its occurrence. So like in previous eddy current method we have seen that we can test the specimen but we will not get the permanent record. Here in case of X-ray or gamma rays we can get the permanent record. So here this particular surface which is shown here, this is less exposed, and this flaw portion has more exposed. So colored, we can see that this with the help of this color we can identify the position of flaws. So this is the working principle in case of radiographic tests. So in radiographic testing, the test part is placed between the radiation source and the film. So this is the radiation source and this is the film, and in between that this specimen is used. The material density and thickness differences of the test part will reduce the penetrating radiation through interaction processes involving scattering and absorptions. Suppose the density of the specimen is large, then definitely it will resist to the rays passing through it. Okay. If density is less, then accordingly the particular material density and thickness, if material thickness is large, definitely this is going to resist to the passage of the X-rays or gamma rays through it. So material density and the thickness of the material specimen, so that differences of the test part will reduce the penetrating radiation. So it will resist to that rays, and that's why penetrating radiations will be reduced in that case, and the differences in absorptions are then recorded on film. So likewise these differences Likewise, here you can see this is the difference. In flaws, the difference is different, and here less exposure and more exposure likewise. So that differences we can observe. So differences in absorption are recorded on the films. In industrial radiographic, there are several imaging methods, available techniques to display the final image. Film radiography, real-time radiography, computed tomography, digital radiography, and computed radiography. So these are some of the examples of the radiography. So here you can observe the real-time radiography, computed tomography, digital radiography, and computed radiography. So these are the different radiography methods which are used in industrial applications. The radiographic testing is a non-destructive testing method in which there are two different radioactive sources available for industry. So as already we discussed, the X-rays and gamma rays we are using as the sources or radioactive sources in the industrial applications. The radiation sources use higher energy level, that is shorter wavelength versions of electromagnetic waves. Because of radioactive involved in radiography testing, it is very important, it is paramount importance to ensure that locus rules is strictly adhering during operation. Computed tomography is one of the lab-based advanced NDT methods. So already we have seen the different ways, tools, techniques which are used for the non-destructive radiography tests, inside which computed tomography. So computed tomography is one of the lab-based advanced NDT method. In short, we are considering as CT. So CT is the radiographic based technique that provides both cross-sectional and three-dimensional volume images. So we can get both kind of images in computed tomography. So inside which cross-sectional as well as 3D volume images also observe. We can observe with the help of, we can take with the help of this kind of images. We can take with the help of computed tomography. So this is, by that way, it is important. So these images allow the internal structure of the test object to be inspected through inherent superimposition associated with 2D radiography. Okay. So CT, that is computed tomography, which has both cross-sectional as well as 3D volume based images of the objects under inspection. Then coming to the benefits of the radiography test, it can inspect assembled components. Means in case if any assembly is present in front of us and we have to test the specimens which are present in, say, the assembled this particular structure, then it is possible with the help of radiographic tests. Minimum surface preparation is required. That is one kind of more advantage in case of radiographic test. So in other type of testing, we take the example of dye penetrant test, then we will require the surface preparation, and that kind of surface preparation is not required in case of radiographic tests. Then it detects both surface and subsurface defects. Means the defects which are present on the surface, at the same time the defects which are present inside the specimen, both kind of surface that we can say that defects, flaws, etc. that can be detected with the help of radiographic test. Then it provides a permanent record of the inspection. Already we have discussed about the permanent record. So in case of other, suppose we take ED current test, then it is not possible to keep the permanent record, but here we can keep it. Then verify internal flaws on complex structure. It isolates and inspect internal components, that is important. Then automatically detects and measures internal flaws. Whatever the internal flaws are present inside the specimen, these are automatically detected. Measures dimensions, angles within the sample. So that is very important type of advantage, that it can measure the dimensions also. Whatever the flaws dimensions, that are also measured. Then angle within the sample, that is also measured here. Then it is sensitive to changes in thickness, corrosion flaws and material density changes. So likewise, we can observe with the help of the permanent record which we can see in the form of the film. We can observe the changes in thickness, corrosions, flaws and material density with proper expertise. Coming to the limitation of radiographic test. So as we are using X-rays and gamma rays, there is high risk of radiation. So risk of radiation hazard. Then can be sensitive to defect orientation and could miss planar flaws, which are present inside the flaws present inside the planes that may miss that as it is sensitive to defect orientation. It has a limited ability to detect fine cracks. If the cracks are very fine, then it has limited ability. Then access is required to both sides of the objects. Means on both sides of the objects we will have to require the access. The thickness limitation of the material can be penetrated. The thickness limitation is one of the limitation. Skilled radiographic inspections is required because the particular problem or particular things which already we have seen, like it is due to the thickness, it is due to the corrosion, it is due to the flaws, it is due to the material density, by which reason this particular color change or this particular shape has been observed. So that can be elaborated by the skilled radiographic inspector only, and that's why it is required. And it is a relatively slow process and it requires high capital cost. So these are the limitations in case of radiography tests. And coming to the applications, radiographic testing is widely used in case of aerospace industries, military or defense sector, then offshore industries, marine industries, in marine also and offshore also, both the industries, in power generation industries, in petrochemical industries, in waste management areas or waste management industries, in automotive industries, in manufacturing industries, and in transport industries. So if we look the application area of the radiographic test, then we will come to know that wide type of application, wide varieties of applications are there for the radiographic test. So there is very less area which is remained under this X-ray or radiographic test. So it's very important type of testing method as non-destructive type of testing method. So thank you for your attention for this radiographic test. Thank you.